the death of the sun, the collision of the Milky Way galaxy with the Andromeda galaxy, and possibly the Big Rip.
This is a huge discovery, and we think that it's a huge discovery. The most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
We believe that this is a significant finding. Finding things that we didn't expect or could not explain is the most fascinating part about this camera, this amazing instrument that we have deployed, because it forces us to reevaluate how we perceive the world. The primary cosmological hypothesis that describes how we came to be is the Big Bang theory. However, the James Webb Space Telescope has found evidence that challenges this notion. According to Neil deGrasse Tyson, the Webb Telescope discovered the black hole of the previous universe, which gave rise to our own. Perhaps the moment has come for us to acknowledge that the world has to be changed. But to what extent? Come along as we examine James Webb's discoveries, which are priceless to scientists. Is it possible that their measurements or their understanding of the Big Bang are off? C. The development of the gold hypothesis was among the most significant accomplishments of the previous century. According to the idea, the world as it is now evolved from a hotter, denser, and more uniform state. When fireballs, now known as the cosmic microwave background, were discovered in the 1960s, the theory, which was previously thought to be a credible explanation for the universe's expansion, became widely accepted. For almost 50 years, the Big Bang hypothesis has been the most reliable explanation for the beginning of the universe, the inflationary era that preceded it, and a certain condition of affairs. However, astrophysicists and scientists have long contested the Big Bang and the universe's expansion, and James Webb has discovered two additional links. Our picture of the cosmos may undergo a radical change as a result of his surprising discovery of early galaxies. Massive galaxies seen in the early cosmos by the James Webb Space Telescope raises questions about our current knowledge of the cosmic framework. The discovery does not quite fit into the available astronomical models. With barely 2 years of operation under its belt, the James Webb Space Telescope has already given us a peek into the early cosmos, a few 100 million years after the Big Bang. Many's perspectives were altered by the James Webb Space Telescope. Abruptly, we realized that the entire history of the universe could need to be redone. Astronomers have found 6 more massive galaxies than stars on Earth using the James Webb infrared detection technology. Our understanding of the genesis of galaxies may be altered if the sizes of these centers are verified. Based on information gathered by the James Webb Space Telescope, the research, which was published in the journal Nature, reveals that the Earth's age is just 3% of what it was 13.5 billion years ago. Then why are these galaxies so enigmatic? Galaxies began to resemble our Milky Way galaxy 13 billion years ago, an amazing development that occurred just 500 to 700 million years after the key event that heralded the formation of our planet. This object contains a star that is billions of times more massive than our Sun, and it may be a giant 100 billion times larger than our Sun. To put things in perspective, the stellar mass of the Milky Way is equivalent to 60 billion suns. In that sense, these galaxies dwarf the Milky Way in size. The University of Colorado Boulder's Erica Nelson, an astronomer who wrote the article, expressed amazement that a gap this size could form so swiftly. It defied logic to assume that galaxies with stars like our own would arise quickly in the early cosmos. Concurrently, the dust mound progressively grew in size. This view suggests that the issues facing the early world progressively came together. Nevertheless, these justifications fall short of explaining recent findings. How quickly these creatures grow is a subject that research director Evil addresses. The finding disproved the theory that the universe's massive galaxies required a very long time to form and called into question accepted scientific knowledge. Experts in astronomy refer to these objects as cosmic disruptors, informally, and they certainly live up to the moniker, appending and altering our conception of the universe's evolution. If this discovery is genuine, it might significantly alter our understanding of the early cosmos, according to astronomer Emma Chapman of the University of Nottingham in the United Kingdom, who was not involved in the research. It has been claimed that stars may have created more frequently than previously believed in the dark cosmic age, as evidenced by the finding of huge galaxies close to the Big Bang. However, scientists are cautioned before they begin to alter the course of cosmology. There's still a chance some of these objects might be concealed within a giant black hole. Gravity may have caused gas and dust in the image to collapse into what seems to be a star. The intricacy of the black hole's early development and growth is still unknown, according to a different scientist who was not engaged in the study. He said that rather than reflecting cosmology, the facts call for knowledge of the novel mechanism governing the formation and growth of the universe. Spectral images of items that reveal their age. The redshift of early universe galaxies indicates that their light is more stretched as it travels to Earth. The greater the redshift number, the more the light is stretched, signifying the galaxy's age and distance. Spectroscopy can indicate whether or not redshift candidate galaxies register as reddish galaxies from a recent cosmic epoch, as well as how ancient they appear to be. In order to observe, despite the outcome, astronomers claim that the detected quality constitutes an amazing occurrence, albeit further observations are required to confirm the discovery. There might be 100 times more stars from this cosmic age than previously thought. The University of Texas at Austin's Michael Bone, the author, views the issue differently even if the sample size has been halved. By publishing his findings in Nature Astronomy, he aimed to determine the percentage of regular matter that would require star formation in order to monitor the huge galaxies that James Webb had seen. He said, star formation used almost all of the available atoms. But according to Bone, achieving 100% efficiency with this method is almost unachievable. He said that by contrast, the current global percentage is only about 10%. This calculation's robustness originates from few assumptions. Does this imply that Vogelsberger's estimates are incorrect, even in spite of Bone's calculations? Lambda dismisses CDM. It was his final destination before choosing to replace it with another idea, he claimed, adding that no other thought was now impeding his powers. What additional reasons are there then? Approximately 500 million years after the Big Bang, Hilly Williams' team at the University of Minnesota made the stunning discovery of an early galaxy. Based on James Webb as well, the measurement device's resolution determined how blurry galaxies appear to be. Williams reported a star production rate 12 times greater than that of galaxies from a little later era. Though he assessed the likelihood of this star formation for bigger galaxies at similar redshifts, Williams confirmed that the galaxy was no more massive than the galaxies analyzed by Bohan. Its modest size, just 105 light-years in diameter, makes Bone cautious as well. It is smaller than the average galaxy. It was decided that the cluster would be worldwide. The lambda CDM can be modified as an additional solution to the problem in cosmological models. Dark energy's behavior appears to have changed shortly after the Big Bang, according to the early electron hypothesis. By making this change, it becomes consistent with the Hubble constant and keeps up with other observations. More issues in the early world are needed for this approach. According to Bone's calculations, there would be a threefold rise in the velocity of matter in the first galaxies, negating the necessity for ultra-low star formation of the same magnitude. Age differs significantly from the 13.7 billion estimate based on other metrics. The fact that part of the Milky Way's light can be mistaken for stars by astronomers is another explanation. Bohan considers the hypothesis that the light may be coming from the supermassive black hole's storage region to be excellent. Astronomers caution that while they have observed a few of these galaxies thus far, they may not be representative of the entire universe, as there are only perhaps 250,000 of them in the sky. A statistical analysis would settle the argument, according to Joel Leja of Penn State University, who was not engaged in the research. But the issue is, are these far-off galaxies really that? Distant, huge galaxies may be mimicked by neighboring low-mass galaxies, according to Peter Beruzzi of the University of Arizona, who was not involved in Bourne's research. More assessment is awaited on the ultimate outcome. Moreover, there are no spectroscopic data available for these galaxies, which would enable the determination of their actual distances and allow the hunt for black hole signs. After reviewing the material provided, Michael Bohn concluded that a major issue will emerge in a few years or fewer. Let's examine some of the possibilities astronomers have proposed to explain this occurrence while we wait for this information. If we accept that supermassive black holes may have existed in the early cosmos, this riddle can be resolved. This idea is thought to help explain why big galaxies show up in telescopic views, according to astronomers. However, the challenge is to account for the large number of black holes that emerged in the early cosmos. Herein lies the relevance of the contentious Nobel laureate. Popular historians claim that everything that exists now and in the future, apart from around 14 billion years ago, exists in a separate dimension. All that is apparent to us is the result of this difference breaking down and creating. This is the most basic explanation of the Big Bang. But 13.7 billion years does not seem long enough, in the opinion of many scientists, to develop sophisticated structures like superclusters. To bolster his argument, an Oxford University physicist has questioned the conventional Big Bang theory. Based on the remnants of cosmic microwave background radiation, which was produced when Earth was just 300,000 years old, the scientist concluded that a vast circle rather than the Big Bang was the genesis. The cosmos enters a new phase with every event. There will be another Big Bang in the future, according to Sir Roger Penrose, the 2020 Physics Nobel Prize recipient, who is renowned for his contributions to mathematics and the study of black holes. Our universe has seen many Big Bangs. In the process of illustrating the depth of the material and finally crafting phrases that capture the sense of eternity, he also investigated the intricacy of black leather. Penrose maintained his skepticism and called the prize crazy when he accepted it. A second Big Bang and the creation of a new universe will result from the cosmos' expansion until all matter decays. It has already occurred and it will again. In what way, therefore, do scientists defend his conformal cyclic cosmology? By asserting to have found 6 hot spots, known as Hawking bits, each roughly 8 times the diameter of the Moon. Sir Roger Penrose refuted the widely accepted Big Bang hypothesis. Although these black holes are not like the 13.77 billion-year-old Earth of today, their discoveries suggest that they may exist. The name black hole comes from physicist Stephen Hawking, who proposed the theory that black holes generate electricity and eventually evaporate. The layer of nature that started before the real Big Bang is the only explanation for the unique, low-entropy state at the universe's creation in the inflation-based Big Bang scenario. Penrose proposed that as our universe expands to its ultimate limit and becomes empty, cold, and black, it would revert to a low-entropy condition. The existence of death black holes, which are relics from countless years ago, attests to this and might support Hawking's hypothesis. Evidence for an anomalous position of temperature in the cosmic microwave history was offered by Penrose in his 2020 paper published in the monthly notices of the Royal Astronomical Society. Roughly 10,000 simulations were used to analyze the data for these sites, which came from the Planck 70 GHz satellite. Due to black hole evaporation, Penrose discovered high temperatures in cosmic microwave background radiation in 2018. The gravitational waves responsible for the rings were previously observed when black holes collided throughout the cosmos. Black holes demolish stuff and leak energy. When the universe's expansion comes to a halt, they aid in lowering entropy. The leftover black holes will either condense or combine to form new ones. This leads to the appearance of the Big Bang scenario, which smooths out the present jagged geometry of space-time. Penrose's concept proposed that the next Big Bang will mark the end of the universe's expansion and its collapse into a finite cosmos, ushering in a new era. The common belief that variations in CMB temperature must be random is refuted by Penrose. He and Gerzhetian discovered over 12 loops in NASA's WMAP satellite data, indicating the possibility that gravity did not exist in the past. If true, Penrose's coherent cyclic cosmology would do away with the necessity for a Big Bang leader by suggesting that the age of our universe may be indeterminate in the billions of years. If verified, this would represent a significant and demanding claim in the field of cosmology. Opponents argue that, as the world becomes older, everything should get smaller since it is difficult to combine an endless universe in one century with a little world in the next. Tell us if Penrose's idea makes sense or if, like so many others, it should be written off as a Big Bang theory. Thank you so much. Please like and subscribe.